Okay, let's go over these answers to this practice quiz. This will be sections 2-1 to 2-3. So the first question, we want to be able to tell if this is a valid statement, valid conclusion. So here's the first statement. If you drive the speed limit, then you will not get a ticket. If you do not get a ticket, and notice we repeat this, will not get a ticket, will not get a ticket, then you will not get any points. And then here's the conclusion. If you drive the speed limit, then you will not get any points. This is definitely valid. This is an example of, excuse me, the law of syllogism. So, law of syllogism. So, this is the law that's very similar to the transitive property. If A equals B and B equals C, then A equals C. Very similar process. So, since this is true, we don't need to come up with a counter positive. Okay. So then the next one, we're asked to find a counter example. Okay. So we're just told that ray AB divides angle CAD into two angles. So ray AB is an angle bisector. Okay. This is clearly not the case. We would need to create two congruent. So it's very easy to show that we can make an angle. So I'll draw a diagram first. Okay. So here's my angle CAD. And to be a bisector, it would have to be divide this right in half, okay, where the two smaller angles then would be congruent. So if I have this, I can easily show that this ray AB, so put a label as B, I can show you that angle CAB is a lot smaller than angle BAD. They will not be congruent, okay? So you can just mention that your angle CAB could be, and depending how you draw it, bigger or smaller. Bigger or smaller than angle BAD. BAD. They're just not going to be congruent. Okay, so one could be, so the measurement, we can just make up a problem. We could have one that's 35 degrees. The other one could measure 55 degrees. Okay, there is a counter example that shows my angles that were basically, we took this and we divided this, but we don't have to necessarily divide it in half, okay? If it was an angle bisector, then we would create two congruent angles, okay? So then the next one, if x is a positive number, so again, think your positive numbers, you know what that is, and then we're told that the value of x cubed is always greater than the value of x squared. So the first thing that may pop in your head is, hey, let me try 3. And I will tell you that 3 cubed is bigger than 3 squared. So a regular whole number, not going to work. We have to use a fraction. So if you say let x be a half, then when I cube a half, okay, if I take 1/2 cubed, I get 1/8. Okay, we compare that to squaring 1/2. 1/2 times 1/2 is 1/4. And right here is a counter example where my x squared is actually going to be larger than x cubed. Okay, so that's the type of problem that I need you to be able to do. Now, it also works for 1. Okay, so you could use x equals 1. So if 1 popped in your head, you're going to get a statement of 1 cubed, which is 1, 1 squared, which is 1. 1 is not greater than 1. Okay, so right there proves that there is also a false statement. Okay, so we're coming up with just one. You only need one example to prove that a statement is not correct. Okay, so it may work for most of them. Like I said, any whole number, this would be a true statement. But when we, except for one, but then when you introduce some fractions or decimals, then you're going to see that it doesn't hold true. Okay, so then the next part, we want to use the law of detachment to determine if you conclude from the given information. If not, if possible, if it's not possible to make a conjecture, then just say not possible. So this is where I must give you the hypothesis again. So the law of detachment says, okay, so let's look at this. If you get an A on a test, then you will get a sticker. You get your egg, or your A, and then you can conclude you will get a sticker. Okay, they're basically saying, here's the hypothesis again. We get our A, then we can say that the conclusion will be true. Okay, so now here, be careful of this one. If the roads are icy, then school will be closed. School is closed. That's the conclusion. So using the law of detachment, this is not possible. Okay, not possible. Okay, and then this, if possible, use the law of syllogism to write a new conclusion. So this is where my conclusion and the hypothesis have to match. Okay. So in here, we don't have matching, we have matching conclusions. Can't apply the law of syllogism. I need a conclusion and the hypothesis to be the same. So these two middle parts have to be the same. Okay. Or this, like the hypothesis and conclusion has to be the same. So since I don't see that, it is not possible. Okay. If not possible to make a conclusion, then just write not possible. So again, this should be pretty up. Don't overthink the law of detachment. Don't overthink the law of syllogism. Okay. So hopefully this first page makes sense. Okay, on to the next page. Here for this number 7, what I'm hoping that you're going to see is that my hypothesis and conclusion we have in common. Okay, so really the conclusion here is that if here's the hypothesis, if the school is canceled this morning, and then we see that again right here. If school will be canceled, okay, school will be canceled, school is canceled, they are the same. So then our statement can be, if the power goes out this morning, then you can sleep late. Okay, that is the law of syllogism. Law of syllogism. And what I'm looking for is this is repeated. Canceled, school is canceled. School will be canceled. Okay, same statement. And we take that part away and we can write a new statement. Okay, so just make sure you understand that is part of deductive reasoning. Okay, so then the next section, all multiple choice, decide whether inductive reasoning or deductive reasoning is used to reach the conclusion. Explain your answer. So what I need, well, that's actually for this part. So this is deductive reasoning for number 7. Okay, deductive reasoning, that's when you're using logic. Okay, inductive, you're looking for a pattern. So this is deductive. Then we get to the multiple choice part. So just make sure you realize this is deductive reasoning. Okay, again, we use the law of syllogism to be able to come up with the new statement. Okay, this next part. Every day after school, your mom gives you a snack. So when you get home from school today, you will get a snack. So this is a pattern. Okay, we're observing this pattern that every day you get a snack when you come home. That is part of inductive reasoning, and we're seeing that it's a pattern. Okay, so all mammals are warm-blooded. Snakes are not warm-blooded. Your pet snake is not a mammal. Okay, that is simply using facts. Okay, so that's part of deductive reasoning. Okay, so then this one, each time a player is late to practice, the coach makes the team run an extra lap. So next time someone is late to practice, the team will run an extra lap. Okay, so for number 10, we see a pattern again. Okay, that is inductive reasoning. Okay, I guess I should label this. So A, this one was D, this is A, inductive reasoning. Okay, the next one, the sum of the measures of an interior angle of a polygon is 180 times the quantity n minus 2, where n is the number of sides. A triangle is a polygon with 3 sides, so the sum of the measures of its interior angles is 180. Again, this is using deductive reasoning because we are using facts. Okay, so once again, we're back to D. Okay, so this part, state the law of logic that is being illustrated. So it's a 50-50 chance. If you are 16 years old, then your parents will buy you an iPhone. Okay. Actually, I misread this part. If you are 16 years old, then your parents will buy you a cell phone. If your parents buy you a cell phone, then they will buy you an iPhone. That is our law of syllogism. Okay. So we can take out the part that we repeated and we come up with a new statement. Okay. If there is ice on the roads, then you should avoid driving. There is ice on the roads. Okay. They're just restating the hypothesis, the first part, the P part, and then the conclusion will also be true. That's the law of detachment. Okay. So this was B. This is A. Okay. So I'm hoping those reasoning skills that you can understand the difference between inductive, where we're looking for a pattern, and deductive, where we're using facts. We can see if we can apply the law of syllogism or the law of detachments. That's all part of deductive reasoning. Okay, so I'm hoping this page made sense to everybody. Okay, on to number 14. 14, they want us to write a biconditional statement. So that's this part. If and only if. Okay, so I can get rid of the if part. I can say an angle is acute if and only if it has a measure between 0 and 90 degrees. Okay, so again, that is true. P then Q, Q then P, both statements are true, and therefore I can write it as a single statement using the words if and only if. Okay, so same thing happens here. We have a straight angle. Okay, so I can just say an angle is a straight angle if and only if it has a measure of 180 degrees. Okay, so it should be very simple to be able to write a biconditional statement given an if-then statement. Okay, so again, don't write the if, don't write the then part, and in the middle, in between the statements, you put if and only if. Okay, so again, I could read it this way. Okay, if an angle has a measure of 180, how come I didn't spell measure correctly? Measure. Okay, if an angle has a measure of 180, then it's a straight angle, okay? Both P then Q, Q then P can be written as a biconditional. Okay, then the next part, it says write two conditional statements that make up the biconditional statement. So now I want you to go in reverse. So we're taking this biconditional statement and write it as an if-then statement. So first part, I can say if the polygon is a quadrilateral, then it has four sides. Okay, that's P then Q. And now I'm going to write if Q then P. Okay, if, and I'm just going to take this statement, if, and I'll say a polygon. A polygon has four sides, then it is a quadrilateral. Okay, forwards and backwards. That's if-then statements. Okay, so then I'm hoping that you're going to see this pattern pretty quickly. Okay, we're going to need to realize this, it goes from 2, and then we have 1, 2, 3, 4. Then we go to 1, 2, 3, 4, 5, 6, 7, 8. So we keep doubling it. We're going to need 16, and I'm going to do a horrible job. I'll try to do my best job, but we're going to divide this into 16 equal parts, where it's going to be 8 white and 8 shaded. Okay, so I'm not going to take the time to do that right now, but you can carefully, do that. Okay, so it says then the next part, it says make and test a conjecture about the sum of any 3 even integers. Okay, so with this one, you have to realize what makes an even integer. Okay, so make and test a conjecture about the sum of any 3 even integers. Let's make sure that you have some examples. So I'm going to go 4 plus 8 plus 10. Okay, and you're going to get 22. Okay, come up with another example. So let's try 12 plus negative 4. You can do some negative. Negative 4 is still an even number, plus 2. And what you're going to get is that's going to be an 8. 8 plus 2, that's going to be a 10. So what I'm going to say is it looks like we should always have an even number as the sum. So that's my conjecture. I'm looking for a pattern. I'm seeing that it seems like we will always get an even number. The sum will always be even. That's my conjecture. And then I would have to, see if I could, come up with a general statement using algebra, which again, I just need you to just have this conjecture. It's looking for a pattern. It seems to hold true, but if someone could come up with a counterexample, that you only need one counterexample, but I know for a fact that the sum will always be even if you add 3 even integers. Okay, on to number 19. We need to have 3 odd numbers, and we're taking the product. Product means multiply. So let's take a 5 times a 3 times a 7. Okay, so use a calculator, use whatever, you do it in your head. 5 times 3 times 7, we get 105. Okay, let's come up with 11 times 5 times 3. 11 times 5 times 3, which is going to be 165. So it seems like the product is going to be an odd number. So please come up with one more example. That's going to be my conjecture. I believe that if I multiply any 3 odd numbers, let's do a 9 times 13 times 27. 9 times 13 times 27. Again, you just have to show a couple examples. And then it seems like we can conclude that we will have an odd number. So my conjecture is the product will be odd. Okay. I feel pretty good about that statement. Okay, this last part, you're going to quickly write statements based on the fact that I tell you our hypothesis is the P part is you drive a Mustang, and the Q, you like Ford cars. Okay, so then we're supposed to negate the P, you do not drive a Mustang. Okay, that's how easy it is to be able to negate that statement. Okay, so then if P, if you drive a Mustang, then you like Ford cars. Okay, that's a simple if-then statement. Here, this is our if and only if. That's our biconditional statement. So get rid of the if. You drive a Mustang if and only if you like Ford cars. Okay. And then here, this is the inverse. It's going to be negating if you do not drive a Mustang, then you don't like Ford cars. Okay, designed to be easy. This is a contrapositive. We start with the conclusion. If you do not like Ford cars, then you do not drive a Mustang. Okay, that's all our conditional statements that we learned. Okay, so hopefully that makes perfect sense to everybody. Should be easy on your quiz. I'll try to give you a relatively small phrase for both the P and the Q. Okay, so hopefully you understand that. For number 21, we're looking at the conditional statement. If it is Halloween, then it's October. So Halloween occurs October 31st. So if it's actually Halloween, of course, we have to be in the month of October. So this is a true statement. Okay. Right, the converse is the converse true. So the converse tells you to take the conclusion. If it is October, then it is Halloween. Well, when I'm recording this, it's October 10th. It's October, but it's not Halloween. So that's a false statement. Okay. Then it says, write the inverse. Is the inverse true? So the inverse tells you it's the not P, then not Q is the inverse. So if it is not Halloween, okay, then it is not October. Well, this statement is again false because it's not Halloween today, but it is October. So that is a false statement. And then the contrapositive says not Q, then not P. So if it is not October, then it is not Halloween. Okay? So if it's November, you can guarantee then it's definitely not going to be Halloween. So this is a true statement. Okay? So the last part of this, we're writing if-then statements. All squares are rectangles. So we're supposed to rewrite this as an if-then statement. If and I'm going to use the word quadrilateral. The quadrilateral is a square, then it is a rectangle. Okay? X is less than 0 if X is less than or equal to 2. So you put the if part. If X is less than or equal to 2, then X is less than 0. Okay? And then here, just be careful the word because. It says circle the hypothesis and underline the conclusion. So this is the hypothesis. Okay, so we're supposed to circle the hypothesis and then underline the conclusion, rewrite it as an if-then statement. So if I have cold feet, then I wear slippers. Okay. Hopefully that seems obvious. Oh, I didn't realize my camera did not show that part. So make sure you understand how to write if-then statements. Should be very easy. I will be very clear which one is the hypothesis, which one's the conclusion. Okay, question number 25. You need to refer to this sheet. Okay, so I'm giving you a line and then I'm putting 2 points on that line. I need you to realize that's the line point postulate. Okay, a line, so you just have a line, contains at least 2 points. That is what's being illustrated for number 25. Okay, so line point, which is D. Okay. Then I'm telling you in number 26, I have 2 planes and they're intersecting. And what you're supposed to see is that when they intersect, it forms a line. Okay, so if you look down here, 2 planes intersect, then their intersection is a line. That's the plane intersection postulate. Again, most of these are supposed to, use some common sense. Plane intersection postulate, which is A. I always forget to write these up here. So there's D, so D, then A. Okay, so here, this diagram is suggesting that we have 2 lines that are intersecting, and when 2 lines intersect, they form a point. Okay, so if I look here, it looks like we're doing this one where 2 lines intersect at a point. That's the line intersection postulate. Again, these are pretty straightforward line intersection postulate, D. Okay, so hopefully those were really easy. And like I said, I am allowing you to use this during the quiz. Okay. It should all make sense, these postulates. Okay, last page. I'm asking you which statement, if any, is true about the diagram. So we're supposed to circle all the ones that are true. So I need you to realize that this array, EB, it does bisect because we're given this 90 degree. Without this symbol right here, I don't know. It may look like it's a 90-degree angle, but both these are the same. So A is true. So I'll put an A up here. And then we can tell that AEB is also 90 because, again, supplementary. This is 90. That forces this to be 90. Okay. And then we're told that point E is the midpoint. I can't tell that. I would need someone needs to put little slash marks to say that segment AE is congruent to EC for it to be the midpoint. So, and then D is not true. Okay, this next one. So let's put a C up here. So it's A and C. A and C for number 28. For number 29, you need to realize you cannot say these two angles are complementary. Okay, I don't know that that's 90. I don't see that it's a 90-degree angle, therefore I can't assume it's 90. Okay, and then this statement, BA, so BA and BC, they are not going in opposite directions. Okay, it has to form a line. So to be opposite rays, it has to form a straight angle. And I have a 90 or close to a 90. Again, I don't know if it's exactly 90, but they're definitely not opposites. And then points A, B, D obviously are not on the same line. So none of these statements are true. Okay. So then the next part, determine which statements about the diagram you cannot conclude. Okay. So we're only going to circle the ones that we cannot conclude. So lines P. So let's find line P and Q. They intersect at point F. I can clearly see that. I can see that one. Okay. Points E, B, and C are collinear. Okay. I don't see a line going through those, so I cannot conclude that. So this statement, I can't conclude from the diagram. Okay. So then I tell you line Q. So line Q is this one. Line P is this one. We're told that they're perpendicular. I can't tell that. Even if you can kind of tell that it doesn't even look like a 90. Even if it looked like a 90-degree angle without the symbol, you can't conclude it. Okay. So then we're told C, A, B, and B, A, D are supplementary. I can conclude that because it's part of a straight angle. So the two angles would have to add up to 180. That's our definition of supplementary. And then AB, so ray AB and ray or line CD, they are perpendicular to each other because I see a 90. So the only two that I can't conclude from the diagram, B and C. Okay. So again, I'm hoping that you understand all 30 problems on this practice. Okay. Use your notes, refer back to your notes. And if you understand all these problems, you go back and look at some of the big idea assignments that we did together, you should be more than ready for this quiz. Okay. So thank you for watching. Take care.